What's up, Mike?
What's up, Tommy?
What are we talking about today?
Today we're talking about PMs, or preventative maintenances.
Yeah, and a lot of times, what do they refer it to as that we are not exactly a fan of?
A multi-point checkup or tune-up.
Tune-up. Tune-up is the one I have a problem with. And the reason why I have a problem with a tune-up is there's really nothing you're tuning up on a system. Very few people have anything that is to be adjusted on their equipment. Some commercial units have belts, some, very few residential have belts, but you're really just tightening the belt for it to keep its fan speed. And since I would say 99% of the households, you're not doing any adjustments. Well, what are we checking though, Mike?
What we are checking is whether the unit is actually going to function in the mode that we're checking for the season that we're going into.
Yeah, so right now we're in fall, and fall is going to be checking heating. And just so that we're all clear, this isn't a script, these are just note points. We're not scripted, this is completely free.
Off the cuff.
Off the cuff, exactly. So there are 2/3 types of AC units that you typically work with. You got heat pumps, which sometimes are called electric heat equipment, but they're heat pumps. And then you have gas. And the third type is what's called a dual fuel. It has heat pump and gas. Sometimes on small equipment, they have just electric, which means that you use a cooling only system. And with electric heat strips, the same kind of things are checked on a heat pump as it is an electric heat system. So we just kind of lump that together. But for the most part, what 90% of our customers have is a heat pump. We service a lot of residential houses that are out there where there's no gas. Every once in a while, you'll find a propane one. Most of the time, they switch those out because they don't like replacing their tank twice during the summer or during the winter.
Much more expensive.
Yes, it is. So a preventative maintenance, or a PM, and like we said, we don't like using the term tune-up. It's even hard to get out because it's not like your car. You don't have anything you're adjusting, any sort of movements that you're trying to do. If there's an adjustment that you're making, more than likely it's because there is something else that is causing you to adjust. So sometimes people say, oh, I just need to top off the charge. It's a sealed system. You shouldn't have to charge. You shouldn't have to add charge to it.
If you having to add, that charge went somewhere and there's a problem.
Yeah, exactly. So you adding charge, it's not tuning it up. That's just masking the problem, which is that there's a leak. So the main difference in a heat pump versus your regular cooling unit is what's called a reversing valve. That's basically the only change that you have from running your system in cooling in a heat pump and running it in heat is that reversing valve. It's just a valve that switches the flow of refrigerant. So what you once had inside coil that was cold and an outside coil that was hot, general layman's terms, you now have a reversing valve that reverses the flow of refrigerant. So now your indoor coil is hot and your outdoor coil is cold. Main things that we check on for that is, one, of course, the actual function of that valve. We want to make sure that it does slide over, that it will reverse the flow of refrigerant. Other than that, there's a couple things that we do just like a regular summertime maintenance is we check coil. We want to make sure that the coil is clean. Coil cleaning is very vital because of the airflow. Airflow has to happen. If you don't have air crossing over that coil, you're not doing any heating or cooling. You need airflow. So we definitely check that. The other thing that we check on is heat strips. Heat strips is also called emergency heat or backup heat. Those heat strips is a heat coil that is just electric heat. Typically, it's used in a function of an emergency situation. Your system's not heating anymore. because there's a problem with your system and it switches to emergency heat. The other function that it could have on certain equipment is you have what's called an outdoor temp sensor. It says it is too cold outside to grab heat from outside to bring it inside, because that's how refrigerant works. It says it's too cold, we don't have enough heat, we're not going to be able to heat up the house. So now we're going to run our electric heat, which just, again, it's just like any sort of radiant electric heater. It's just going to have this these little spool of wire that heats up, glows red, and it blows air across it, so it just adds heat to the air. So those are the main things that we check. The things that people are weary about or don't know about, especially if it's the first time, say they moved here, they used to have a gas unit. It does happen with a gas unit, but a little bit more noticeable with electric heat strips is, especially if you have a heat pump and you've never had an issue and there's never been a time for your electric heat strips. Now it got too cold, you moved up to the mountains or something, and you're using an electric heat strip, is the dust that burns off that heat strip. There's been countless times where I have forgotten to mention to the customer, hey, there's going to be a burn smell. It's going to happen. You're burning off that dust that collects over the summer on those heat strips. We kick them on. It gives that burn smell, and then they're looking at me like I caught their house on fire, or they're looking to call the fire department because they think something's wrong. It is a normal function. It does happen. People who are regular users of heat pumps or electric heat strips know of the smell. People that aren't too familiar with it do end up having that panic. Don't worry. If it should dissipate within minutes. If it doesn't, and you're doing it yourself, or you just started it for the first time and it seems to linger on for a little longer than a couple minutes, that's when you go ahead, let's shut down the unit, give us a call so we can check it. But for the most part, that should be a normal function. It just burns off all that dust and then you're done. Mike, you want to talk about the gas, what we do with that?
So for a gas system, what we're mainly checking when we show up is to make sure that the gas is going to flow, that the flames are going to ignite, and that all the components that are incorporated into the safety system of a gas furnace function. So the signal for the system, or not signal, but the path of logic that the system follows when it's turning on your gas furnace, the electricity runs through multiple different components that are safety checks. They make sure that the unit's doing what it's supposed to do at the appropriate times before it turns on gas, before it allows it to ignite and create a fire. If any of those systems isn't running or working, or if any of those components is out, it's going to break the power for that gas valve to be able to turn its gas on, and it's not going to allow the system to run. That's probably one of the most important reasons for us to do a preventative maintenance, especially for gas systems, is to make sure that all of those safety components actually work so the system will even turn on at all. The components are very simple to change out. They're designed to fail and to not last forever, so it's not a strange thing for it to fail and need to be replaced, or even just be cleaned. I think that's all I have as far as the gas furnace.
To add to that, you have a couple components that we look at. We have what's called a draft motor. There's induction draft and forced draft. Doesn't really matter to the layman. It just means either we're pushing that flame or we're pulling that flame. The draft motor is a common part that goes out. A lot of times we check amp draw. It's a very small amp draw. We always check amp draws on any sort of electrical components that has a motor. Sound is something that we check. We want to make sure there isn't rattling or something inside there that might cause problems. But we also want to check if that motor is spinning, that what's called a pressure switch. It just makes sure that is an actual pressure differential saying that, hey, we do have airflow so we can kick on that gas valve. The other things is what's called a flame sensor and a rollout switch. Those were what Mike was talking about with those safety switches. A rollout switch always should have power through it. If it senses a flame, what it's going to do, it says, hey, we have a blockage, we have a restriction, or the fan motor, that draft motor, isn't powerful enough. Now flame is coming back. We're sensing that flame, we're going to kick this system off immediately. We're going to go in emergency shutdown, we're going to lock out the system. Same with the flame sensor. The flame sensor, that one has a little bit of a difference. Some equipment, what it'll do is it'll go ahead, open up that valve, ignite the flame, and then say, okay, I sense the flame, so we can keep the valve open. If at any point that flame starts flickering or anything and it doesn't detect that flame, it'll shut down the system. So a lot of times when people say, hey, I kick on my unit, it works for a couple minutes or a couple seconds, and then it's gone. Well, actually what's happening is that flame is dancing around. That could be multiple things. A lot of times it's spiders that are in your little orifices. It could be just dirt or some sort of blockage. Or one thing that I've found is we've had one customer who live up on a hill, and every time the wind blew, it blew right across the discharge of that flame, which caused back pressure, which caused that flame to start flickering and dancing. So anytime the wind was blowing hard enough, it would do it. Those are easy fixes. We just need to put a little shield to make sure the air doesn't go through. But those are things that we check. We want to make sure that we have everything, all our points checked on, to make sure your system, when you kick it on, will run and will last. The other thing that we check is what's called your heat exchanger. That's where the flame goes through tubes and goes through. We scope ours, which means I take a little camera. I can't get the whole thing because it's a lot, but the main problem is right where the initial heat is and when it comes out, the initial exhaust. We check it internally as well as externally if we can. If we don't have to disassemble the whole unit to check the external heat exchanger, we will, with mirroring it and visually inspecting it. But with that camera going into that tube, we can see if there's any cracks in the system and if there's any sort of damage or debris that we have to clear out. Those are the main things we want to make sure that isn't happening, because if there's a crack or if there's too much debris that's causing rust and we can't see a crack that could be forming, or a rust spot, that's where I always recommend, if you have a gas unit, to have a carbon monoxide detector in your house. A lot of older houses don't have those, but it's always a good idea, because those cracks, all of that could potentially cause carbon monoxide to come into your house. It's not a scary thing other than it could give you a headache and stuff. You'll notice, especially if you have that carbon monoxide detector. But that's what we want to check. We want to see if that heat exchanger is cracked, if there's any sort of issue, so that we can avoid any sort of, health issue or any sort of problem safety-wise with carbon monoxide, because that's the only thing in these systems that we don't have built in, is a carbon monoxide detector to say, hey, we got a cracked heat exchanger, we got something. Now, there are some indications when it gets real bad. That dancing flame does happen if the crack is on a certain spot of that, so we can see it. That will draw us to, okay, we need to check the heat exchanger, or just, general, nice cracks that we can see visually. We can say, okay, yeah, that is a cracked heat exchanger. Those are the most dangerous parts. But for the most part, these systems are designed pretty robustly. It's not an extremely common thing to have your heat exchanger be cracked, with it being only 10, 15 years old. When you're up in the 30 years, 25 to 30 years, yes, it is more common. But if someone says, hey, you got a cracked heat exchanger, we need to replace this heat exchanger, and your heat exchanger is 5 to 10 years old, you're going to want to know why. It could be a gas balance issue, meaning that it's got too hot of a flame, it's putting out too much gas. It could be a low gas issue. We have to balance the gas. We have to make sure it has the proper amount of gas in the system. That causes oxidation, causes more rust. It just causes more problems. That's why it's always important when you install a new gas unit to do a proper startup and check your gas pressures and everything. Now, we just recently did an install with a gas unit, and we gauged up, we did all the stuff, and it turns out from the factory, with the pressure we had, with everything that we had, it was already right on the mark. We didn't have to do any adjustments, and a lot of times we don't. But that also causes a lot of just, oh, we'll just throw it in there. The last 3 we haven't had to adjust. Why would we have to adjust this one? That just becomes a little bit lazy. We don't want to be that way. You always need to do a proper startup, check it. It doesn't take that long. It is way easier to just check it and know for sure. Because if I don't check it, I don't know about you, Mike, but I'm laying in bed just staring at the ceiling like, is this gonna work? No, I got to check it. I can't handle that pressure. So I'm gonna check it every time.
Everything you don't do haunts you.
Yeah. Yeah. We like to sleep well at night knowing that we did the right thing and we did it properly. We don't like to worry or guess or have any sort of fear that you're going to call us back. Excuse me. Now, with electric heaters, same as any sort of electric heater, it's just electric, just like we touched on with heat pumps. We're going to look at high limit switch. We're going to look at that. You're still going to get the smell. You're going to get the smell with all of them, but it's going to be more pronounced with the electric heaters because you're having direct heat contact. It's not burning off slowly. It is burning off immediately. But to encompass all of them is our general maintenance that we do. We check filters, make sure they're clean. General rule of thumb is you should change your filters every 3 months. Unless you have dogs and cats. If you have animals, you're going to be changing them, especially if they are inside, outside, or if they are high shedders. And depending on where your return is, you may be changing them once a month. Other things is if you use a higher pleated filter, you're going to find out that the higher pleated, the higher MERV rating filter that you have, the more frequently you're going to change that because it's filtering more and more of the air that's going through. We just today went to a customer who she has autoimmune and she gets, real lethargic if there's anything in the air. She uses a very heavy filter. Her equipment, accommodates for that, is okay with having that heavier filter, but she has to change it once a month. That's why we try not to do filter changes on our end. We try to give our customers an avenue of where they can purchase filters and show them where to change them out so that they can change them so they're not calling us every month or every 3 months. They can change it themselves. If the filter is there and we look at it and we see, hey, this needs a filter change, we have no problem. It doesn't take very long for us to change the filter. But it's better for the customers to change the filter. It's going to be way more cost effective. We don't want to have to go get a filter, charge them for the time to get the filter because there's all sorts of different sizes. And if I was to keep every size on my truck, I wouldn't have any room for my tools or anything else.
We don't have a van full of filters.
No, we don't. The other things we check again is supply fan, indoor fan motor. Now with those, we have different types. We have multi-speed and single speed, or dual speed is something that they call it. Still falls along of multi-speed. But we check the indoor fan motor. We check the outdoor fan motor on a heat pump. We check run capacitors. We make sure that when we're done with the maintenance, as much as we can prevent from failing for that season, we will check. A lot of times, contactors, relays, stuff like that, we'll keep an eye on them, make sure that they're good. There's no obvious issues. We tighten all the electrical, but we also have to listen. We listen to how they're sounding. Transformers hum, but there's a difference between a transformer just humming on its own or a transformer really humming where you can hear it real well. That is an indication that a transformer is starting to wear down. Contactor chatter should never happen. It should be a solid connection. If there's any chatter, we need to make sure that we figure out why it is. It could be as simple as a loose connection on there. It could be that the transformer is not sending the proper voltage. Or it could be that it's just over the time, it creates a little pitting on the connection and it's just not able to make a great connection. Again, with checking amp draws, that's going to give us an indication and we just follow where that is. Run capacitors, those are just like batteries. They're going to go out. And they never go out during any sort of great time. Typically it's during the hottest part of the summer and they just go out. But we do check them to see if we can. Very few times can we predict a capacitor going out, but every once in a while we'll catch one and we'll be like, okay, this is supposed to have 10 UF, it has 7, it's still running the equipment, still works. Let's go ahead and replace this, because if it gets hotter or it gets too cold or we run it too many times, it will go out, and we don't want it to go out during, you know, a winter storm where we can't get to you because we're busy getting on everyone else. We don't want to have to wait. That's the reason for these maintenances, is to make sure that, or at least try to prevent, and that's why it's called a preventive maintenance, try to prevent a service call when you have to wait several days for us to get to you, because we have so many calls coming up. Anything else you want to add to that, Mike?
Nope, just other than it's not uncommon, like he was saying, during a preventative maintenance to replace any of those components such as capacitor, contactor, and transformer. Like, those are good parts to change, that if you're noticing, or as a technician, we're noticing that it's declined in its capacity or it's just declined in its performance, that's a good time to change it out, because the last thing we would want a customer to have to do is to repay us to come out and change that part that we already saw was on its way out.
Yeah.
So if we can change a simple part for $20 while we're there, why not?
Yeah. A lot of times, and of course, $20 is on the low end of this stuff, but you know, a lot of times it is a real cheap, ineffective, you know, part that we tend to keep on our trucks. I tend to stock up on capacitors, contactors, some generic relays. Certain equipment will take special, you know, stuff. It's, you know, proprietary, especially if it's on warranty or something like that. We can't always keep everyone's parts, but we try to keep a good general amount of parts on our truck so that we don't have to charge the customer for us to go get the part. A lot of times what I'll do on my maintenance is say I'm doing a fall maintenance like we're coming into, and I notice something that is only affecting the cooling side of the system. I will go ahead and write it in my notes, say, hey, this, say, contactor, because the contactor runs the compressor and the fan motor. Well, we're not using the compressor or the outdoor fan motor on a gas unit. We're only using the indoor fan and the ignition control modules and stuff. I will go ahead and make it in my notes and tell them, hey, when we come back to do a maintenance for the summer, why don't we go ahead and just put in there to replace that contactor? It just saves money. We don't have to add anything to it, and it's real easy, especially if I don't have the contactor on my truck, or if, you know, money's tight, people are getting into the holiday season looking for you know, ways to get their gifts for everyone for the holidays. So I try to give customers options, say, hey, we want to replace this, but we're going to you know, let you decide on whether we do it now or whether we do it just before you need it, give you some time to save up. That's what we try to do as much as possible, is you know, give options wherever we can. So a lot of this stuff that we talked about is how we do things. Other companies will say 37 points. I've heard 45 point. I've heard 100.
It seems like the bigger the number, the more impressive they sound.
Yeah.
But we struggle to figure out where the 52 points that they check are.
Yeah. I don't know if they're saying, hey, each one of those connections that we tighten up is a point.
That would be the only way to get to the number.
Yeah, I would imagine so. There's very few parts that these things are actual working on. You're not working on these large, I mean, for me, coming from the commercial side of large tonnage, huge equipment, I could see 52 points on those large tonnage, huge equipment. We got, you know, 4 to 7 compressors and a whole bunch of different relays, and that would be a lot of points that I'd be checking. But on your general house, you got your compressor, contactor, relay, control board, fan motor, outdoor fan motor, and if if you have gas ignition control module and your 3 safeties that are typically there and a gas valve, just if we were to combine both as dual fuel, which has both heat pump and gas unit, we would have maybe 15 points. We don't know where the other points are coming from. So we just stick with the original. It's called a preventative maintenance because that's what we're doing. We're not trying to mask it or change anything. We're trying to prevent something from going wrong while we're there on a maintenance. So we're just looking, making sure, checking amps, checking everything so that you have a better peace of mind, and we are able to, 1, track your degrade of your equipment, and 2, make sure that, you know, God forbid something happens during the winter when there's a huge storm and you need service immediately and we have other people that are needing service immediately. We'd rather not have to charge you, you know, overtime or any sort of emergency service call. We'd rather get it done for the, you know, try to catch it beforehand. Now that doesn't mean that we will catch everything. There are certain parts that there isn't much we can do. We can kind of predict, we can kind of say, but we don't have a crystal ball. We can't just say, hey, this is going to go out next month. We don't know. You know, there's too many variants, but we could say, hey, it's pretty bad. We probably should change it and let you decide on which way you want to go. Or we say, nope, it's bad. We can see it now. It's going to go out pretty soon. Or with most of the stuff, if we keep on with the maintenance and we keep doing maintenances, we more or less are able to go, hey, by next year, let's go ahead and replace this just to be on the safe side. We don't try to pressure anyone into doing anything right away. We don't try to do any fear tactics or anything. So that's kind of the reason why we don't like the use of a tune-up. I think that's a little misleading because it's not like your car. You're not tuning anything up. I have customers who...
Even a car doesn't really get a tune-up.
right. But still, it's just not... A tune-up is not the word that would describe what we do on these maintenances.
The closest thing we would be able to do to tune a system is adjust fan speed. And if we're adjusting fan speed, we're doing that for a reason, generally because something else is wrong.
Or because it wasn't set up in the first place.
Or it wasn't set up correctly in the first place.
Yeah. So once it's, and that's again brings us to that point of making sure that you do a proper startup. There should be a proper startup on every equipment that is installed. There is a sheet in the back that, you know, tells you what the startup procedure is. I'm horrible about filling those out because I have my own procedure that goes a little bit more in depth because I've through the years looked at things that I'm like, that's not in there, but I've had a call back on, so I'm going to check it. And so, but at the very minimum, that checklist on the back of that install manual should be at least followed in procedure. Most of the time that install manual is chucked, so writing it down on there isn't great, but at least make sure that whoever installs your equipment, you ask them if they've done a startup, if they're checking everything, if they've checked gas pressure, if they've checked, you know, temperature differentials, things like that, and fan speed. Make sure all of that is checked so that when it comes, because they might install it in the summer and it's great during the summer, it's working awesome, and then winter hits and you're like, why am I calling them out? You know, and a lot of companies have, you know, they'll go ahead and be like, well, we installed it, you know, 6 months ago. We're not going to come out for free. We're going to charge you for it. Well, it could have been prevented on that. You know, it's potential that could have been prevented if they did a proper startup and tested that side of the system while they were installing it, and then you wouldn't have had to call them in the first place. So those are the things that we like to address. And if you have any questions, any concerns, you know, we're always available for, you know, any of our customers, or even if you're not a customer and you just have some clarifying questions you want to answer. You know, I've been in the industry for most of my life, and I'm always willing to answer those questions. I like to educate. I think that an educated customer makes my life easier, makes Mike's life easier, and it allows us to show, why we named ourselves Honest AC. We're going to give you the honest truth, and you can go ahead and try to challenge us on any of this stuff. We're going to show you where it comes from, how it works. And before we go, the one thing I want to say to my customers and to anyone, always try to be with that technician if you can. If he's doing a maintenance, if he's doing a repair, if he's doing anything, be there with him, ask him questions. If he has a problem with answering the questions or have a problem with you being there, it may just be his personality, and he may just not, he's maybe an introvert. But for me, I don't really communicate with people other than in my job. And that's because I'm very confident in what I do in my education in this. And I always like to share. It's a little bit of an ego boost to share the knowledge I've gained over the years. And I am very happy to show anyone who's willing to listen how these systems work, how they are, what we do, why we do it, any of that. And that's because I have confidence in what I do. And if you have a technician show up to your house and he seems to be fumbling, he seems to be having problems, it could just be his personality, but I would just worry about whether or not he's just trying to hide his either lack of knowledge, unknown, or if he's just a salesman that you were told was a technician.
I mean, I tend to be pretty quiet on a job because I'm thinking a lot. But if I'm asked questions, there's no shortage of answers.
Yeah.
And I have no problem. No technician should ever have problems answering questions for their customers or providing proof of the diagnosis that you're showing.
Yeah.
Because if I tell you your capacitor is under capacitance and I can't put it on a meter and show you that it is, how do you know?
Exactly. And also, just with our business model and how we like to do things is Mike is always in contact with me. I'm always in contact with Mike. We can't know everything about every piece of equipment, but with our combined knowledge and the knowledge of other technicians that I know that I keep in contact with, we always will get on the phone if we have any sort of question, any sort of concern. It's a lot of times it's just a soundboard. I want to make sure that my diagnosis and my thoughts go to Mike and be like, hey, does this sound right? I'm pretty sure this sounds right, but I just need that second opinion, and he'll tell me yes or no, or vice versa. Mike will call me up, and I'll be like, yep, that sounds right. Or he might have another test that I haven't even thought of to confirm. Mm-hmm. Those are the things that we like to do. We like to make sure that we are a collective. So you're not just getting one technician. You get one technician that's the hands on your job, or two if Mike decides to roll with me on it because we got multiple jobs and they're real close to each other. We might roll together to get them all done all at once. But we are always in communication with each other. I always contact the technicians I've worked through the years, and if there's something I have a question on, or there's some sort of technique or a test that I haven't done or I don't know about or could be beneficial, we always are communicating about that, so that you have all the technicians that are in my phone book at my disposal to make sure that your unit is taken care of.
A few hundred years worth of refrigeration, HVAC knowledge.
You're right. So we got plenty of people. I got retired guys that know the older system that I call, and I got the young guys that are just learning the brand new stuff, and they're still in school today, but they're learning the brand new stuff on more of a regular basis. So we have a good vast knowledge of people that have the capability of telling us where to lead us, on top of which we don't hide whether we call tech support or not. We will do it. If we have any sort of question about a piece of equipment, we're not too proud to call tech support and make sure that what we're doing is correct to what the manufacturer wants us to do and how they want us to diagnose the system. We're not afraid to say, hey, we don't know everything about every piece of equipment, but I do know how to get the information that I need to get the equipment up and running the way it needs to. Anything else, Mike?
No.
All right.
That's it.
Well, I appreciate you guys for tuning in, listening to us ramble for a bit. Hope we gave you guys good information. And hopefully we can get more videos out to you, give you more education. Like we said, well-educated customer makes our lives so much easier. All right.
Thank you.
Bye.